let's unpack this. Today, we're doing a deep dive into, well, two of the universe's most baffling ideas, black holes and wormholes.
Yeah, absolutely.
Our mission here is to sort of cut through the usual stuff you hear, get to the core insights, and really give you a solid grasp.
And we're not just talking abstract physics here. I mean, black holes are genuinely the strangest, most extreme objects we know of. They really push the limits.
Right.
So we'll journey from, their mysterious edges right into that wild idea of wormholes potentially linking parts of the cosmos. This is basically your shortcut to getting up to speed.
Okay, so let's start with black holes. The popular idea is like this giant cosmic vacuum cleaner, right? Just sucking everything in. Is that accurate?
Not quite. That sucking idea is a bit misleading. It's really about gravity. A black hole is a place where a huge amount of mass gets squeezed into a ridiculously tiny area.
Squeezed out?
Unimaginably tiny. And that concentration creates such intense gravity, such a deep warp in space-time that nothing, literally nothing, not even light can escape once it crosses a certain point.
Oh, okay. So it's extreme gravity, not a vacuum hose reaching out across space.
Exactly. It's all about that incredibly strong gravitational pull close up.
And that boundary, that point you mentioned, that's the event horizon. What's so special about that line?
Yeah, the event horizon, think of it as the ultimate point of no return. It's an invisible boundary.
Invisible, okay.
Cross it and your fate is sealed. You're going towards the center. But here's where it gets really weird. Because of relativity.
How so?
Well, for you, falling in, time would seem to tick by normally. Business as usual, relatively speaking.
Okay.
But for someone watching you from a safe distance, say, me,
Yeah.
your fall would look like it slows down. You'd seem to hover right at the edge, getting dimmer and redder until you just fade away.
Whoa. So wait, from my perspective, I just keep falling. But for you, I essentially vanish at the edge.
That's the bizarre prediction, yes.
It's hard to wrap your head around.
It really is.
Yeah.
Relativity basically says reality looks different depending on who's watching and where they are. It challenges that whole idea of a single objective reality, doesn't it?
It definitely does.
Yeah.
So, okay, if the event horizon is the edge, what's actually inside, at the very center?
The center. That's where our current physics kind of throws its hands up. We call it the singularity.
Singularity.
It's supposedly a point of infinite density. Space and time get tangled up in ways our equations, Einstein's equations, just can't handle. They break down.
So infinite density, what does that even mean?
Honestly, we don't fully know. It's like the universe is giving us an error message right there telling us general relativity isn't the whole story.
So basically, a giant question mark sitting in the middle of a black hole.
That's a great way to put it. A huge cosmic question mark, yeah. It points towards needing something new, probably quantum gravity.
Right, this unified theory everyone's searching for.
Exactly. And, Einstein's math didn't just give us black holes. It also hinted at other, maybe even wilder possibilities.
Like wormholes.
Precisely. Wormholes. Another crazy-sounding idea that comes straight out of the mathematics of general relativity.
Okay, wormholes. These are the cosmic shortcuts, right? Tunnels through space-time.
That's the theory. They're sometimes called Einstein-Rosen bridges. Imagine space isn't flat, but curved. You could, theoretically, have a tunnel connecting two very distant points.
How distant?
Potentially linking different galaxies, maybe even different universes, though that's highly speculative. Think of folding a piece of paper so two spots touch the wormhole is the bridge.
So like stepping through a door here.
Yeah.
And instantly being in, I don't know, another galaxy.
That's the sci-fi dream, isn't it? Instant interstellar travel.
Yeah. Imagine flying into one, seeing stars stretch and colors warp, and then boom, you're somewhere completely new.
It is one of the greatest what-ifs in physics. A stable, traversable wormhole would completely change everything we think about space travel.
Okay, but it sounds too good to be true. If the math allows it, why aren't we, using them? Where's the catch?
There are some big catches. First, theoretical wormholes are likely incredibly unstable. They'd probably collapse the instant they formed.
Collapse. Like slam shut.
Faster than you could blink, yeah. Faster than light could even get through. To keep one open, stable enough to pass through, you'd need something really weird.
Weird how?
You'd need something called exotic matter. And the key thing about exotic matter is that it would have to have negative energy density or negative pressure.
Negative energy? What is that? Like antimatter?
No, it's even stranger than antimatter. Think of it as having repulsive gravity. Instead of pulling space-time inward like normal matter and energy, it pushes it outward.
Okay, that sounds impossible. Have we ever seen anything like that?
Not in any significant amount, no. Tiny quantum effects might hint at it, but nothing on the scale needed to prop open a wormhole. It fundamentally challenges what we know about energy.
So we need this stuff we've never really seen to make wormholes work.
Pretty much. Which is why many physicists think that if traversable wormholes are possible, the answer probably lies in that next big theory, quantum gravity, the theory that might unite gravity with the quantum world.
So the key to maybe unlocking these cosmic shortcuts is hidden in the next frontier of physics.
That seems likely, yes. Quantum gravity might reveal whether exotic matter is real or if wormholes are even possible at all.
Wow. Okay, so wrapping this up, black holes really do push the limits, bending time, crushing matter.
They test everything we think we know, absolutely.
And wormholes, they're this incredible possibility, reminding us just how bizarre the universe could be.
Exactly. They show how much is still out there, how many possibilities might exist beyond our current understanding.
It really makes you think. Perhaps one day, you won't just be learning about these cosmic mysteries. Perhaps you'll actually somehow step through one.
Now, wouldn't that be something? A future beyond imagination.